Let's talk about binomial expansion. This is something that you'll have to do when you're working with polynomials in your pre-calculus class. I want to introduce a concept called Pascal's triangle. Pascal was a mathematician that created this helpful, actually he didn't create it, it was around a long time before him, but he kind of expanded on a lot of the work having to do with combinations. Anyways, so when you're working with polynomials, a lot of the time you will need to expand them. So for example, a plus b squared. Now, you might know that this is a squared plus 2ab plus b squared. Now, this triangle is helpful for figuring out what the coefficients are going to be in front of the a's and the b's. And so we could put the 1 here and the 1 here and see that the coefficients are 1, 2, and 1. Now, if you look at this triangle that I drew here with these random numbers assorted, and you go down to the n is equal to 2, we see that the coefficients are 1, 2, and 1, just like in our expansion of a plus b. Now, it gets a little bit tougher when we are doing something like a plus b cubed, because a lot of times what you'll do is you'll do a plus b squared and expand that and then multiply it by a plus b again. And that kind of just takes a long time and isn't a fun thing to do, but we can leverage the n equals 3 row of Pascal's triangle to make this a lot easier on ourselves. And so an easier way to do it would be a plus b cubed is equal to 1 times a cubed plus 3 times a squared times b plus 3 times a b squared plus 1 times b cubed. And we see where these coefficients come from. You can even do this to the n equals 4 case for a plus b to the 4th. Now this will be 1 a to the 4th plus 4a cubed b plus 6 a squared b squared plus 4 a b to the 3rd plus 1 b to the 4th. And so as we're going across from coefficient to coefficient, we see that the a is its exponent is descending. So we have a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, a to the 0th in this last case, and the b variable is increasing. So we have b to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th. And we are simply multiplying it by the coefficients from Pascal's triangle. Now let's just do one example real quick just to show you how much easier this is. So say we have 2x plus 5 to the 3rd. Now the classic way to do this would be to do 2x plus 5 squared times 2x plus 5. And 2x plus 5 squared is 4x squared plus 20x plus 10, or plus 25, sorry about that. And then we multiply that by 2x plus 5. And again, we get 8x cubed. So you have to, I have to slow down a little bit to do this, plus 40x squared plus 50x plus 20x squared plus 100x plus 125. Add all these up, we get 8x cubed plus 60x squared plus 150x plus 125. All right, now we remember that the n equals 3 case of Pascal's triangle gives us 1, 3, 3, and 1. So 1, 3, 3, 1. And so in this case, A is going to be equal to 2x, and B is equal to 5. And so after this, after this one, we have simply 1 times 2x to the third. And then here we have 3 times 2x squared times 5. And then we have 3 times 2x times 5 squared, and then 1 times 5 to the third. Now let's see what happens when we expand all of these. We get 2x cubed is equal to 8x cubed plus 3 times 2x squared is 4x squared. So 4x squared times 5 is 20x squared times 3 is 60x squared plus 3 times 2x times 5 squared, which is equal to 5 squared, which is 25 times 3, 75 times 2, 150x. And then 5 cubed is 125. So I kind of went about this in a roundabout way, but you should be able to arrive at these coefficients here from 2x plus 5 cubed a lot easier if you leverage Pascal's triangle. Hopefully this makes your binomial expansions a little bit easier and less time consuming going forward. Let me know if you have any questions.